In this video, we will compute the line integral of a scalar function. So here we're computing the line integral of the function xy over the curve C, which is a piece of the unit circle. So it says it's the part of the unit circle going counterclockwise from 1, 0 to 0, 1. So here's 1, 0, and it goes to 0, 1, counterclockwise. So the curve goes something like this. Okay, so that's our curve. First thing we need to do is parameterize it. Which, since it's a part of the unit circle, we can just parameterize it as cosine t, sine t. Where cosine t is x and sine t is y. And of course, for this piece, t goes from 0 to pi over 2. Okay, so now let's compute the line integral. So since our parameterization goes from t equals 0 to t equals pi over 2, those will be the bounds on our integral. And then we simply replace x and y with the component functions of our parameterization. So x was cosine t, y was sine t, and we still have to replace the ds, which I haven't said anything about yet. But ds, in general, is the length of the velocity vector times dt, or the length of the derivative of the parameterization. So we need to compute what that is. So in our particular example, r prime will be minus sine t cosine t. Just taking the derivative of r of t. And then its length will be square root of sine squared t plus cosine squared t. But that's just 1. So in this case it comes out very simple. The norm of r prime of t in this case doesn't even depend on t, it's just a constant, it's just 1. So here, ds is really just the same as dt, although in general this part will give you some function of t. It just so happened in this case it came out to be 1. So ds for us in this example is just the same thing as dt. Okay. So what we can do here is do a u substitution. Do u equals sine t. So this will just be u du, since du is cosine t dt. And what are the new bounds? Well, when t is 0, u is sine of 0, which is 0. And when t is pi over 2, u is sine of pi over 2, which is 1. So this is just 1/2 u squared from 0 to 1. So the final answer is just 1/2.